Hi guys, I'm Mitz.
Hi, I'm Layne Mims, and me and Mitz are going to show you a few ways to surface your spoilboard tonight. This is Layne Mims, just sitting here getting ready to show you how to create a spoilboard file with Aspire or V-Carve. Create a new file, 32.125 by 32.125. We'll put 0.75 as thickness, it does not really matter. We're going to zero the Z at machine surface and the XY in the lower left corner. Tell it OK. Now we've got our file. We're going to assume a few things. Most people use a 1-inch white side spoilboard surfacing bit, and that's what I use, and that's what I'm going to set up this file for. But it'll work with any file up, if you want it, any bit size. If you want to use a 1/4-inch bit, that'll work fine too. It'll take a while, but it'll work great. So we're going to start out. We're going to go to draw a line, a polyline. And we're going to anchor it in the lower left corner, and we're going to point it in the right direction and type in 32.125. That'll set it exact. We're going to go and set the same thing to the north. We're going to turn it up and set it at, since we're using a 1-inch bit and we want to have a step over of about 80%, we'll use 0.8 times 1. And so it'll be 0.8 value up, and then back to the left, 32.125, and then we're going to go up one more time at 0.8. Now we can hit escape, and you can see the vector right here. It starts, and I'll hit an N for node mode. You'll see it starts at the lower left, it goes up and finishes right here. So that's all we need to do to get something that we can copy over and over. Now from here, this is pretty simple. We're going to go to the array copy down this lower left corner in offset and layout. It'll tell us the size of this. It's 32.125 by 1.6 inches. That 1.6 is important. We're going to put about, let's say, 24 rows up, one column to the right, and then we're going to put the 1.6 inches in the Y direction. X to the right, Y positive up. We're going to tell it to copy, and it's going to make a copy every 1.6 inches up 24 times. We hit copy, and now we see what ran off the edge of our board, so that's good. Hit escape, and it clears us out of that menu. Now I'm just going to take the extra and select and delete those off the top. Now we've got the raster ready to go for our spoilboard. And if you'll see, it's not connected. These are still individual vectors. They're open vectors. But even better than that, we don't have to close them or make them one solid vector. As you'll see here, when I hit N for node, it starts here on the lower left, it goes up and finishes. We click the next vector, it starts in that same point. Since we copied a vector that had a known start position and went in that order, it'll continue to go in that order. So hit N for node off. So let's make our first spoilboard file, toolpath. We will select all that, switch on the top with the arrow to toolpaths. The first thing we always do when we go on the toolpath side is hit set and just verify everything. Thickness, our datum is in the lower left corner, and we're on material surface. And then if you need a clearance height, that's fine too. The Z gap above material, I always set these at about 0.2. If you have anything on there that you don't want to hit, that's a good place to set that. Notice there's a Z1 and Z2 on a Onefinity. Both those are the same. So we're going to continue on. I'm going to hit Profile Toolpath, and we're going to make this a profile online cut. So we'll start up here at the top. Always get in a habit when you're in V-Carve or Aspire to go in the order of left to right, top to bottom. It will take care of you. So we're going to start at 0. We're going to cut depth to 0.2 deep. We're going to select our tool. I've set up a surfacing, but if you don't have one, I'll show you real quick. Just grab an end mill, copy it. When you get the copy, we're going to change the diameter to 1 inch. We're going to change this up here and call it surfacing white side bit 1 inch. Pass depth, you want to get this to be really small for a surfacing bit. They don't like to plunge, they don't like to cut deep. They require a lot of horsepower, so we're going to make that 0.02. Step over about 80%. This way, if you ever make a file using Pocket, it will do the exact same thing. It'll at least keep you out of trouble. I usually run about 13,000 RPM on this and 150 or 200 inches per minute, but I'm going to slow the plunge down to real slow. 30. I'm going to call this tool number, since it's a 1 inch tool, I'm going to call it tool number 1. So I'll apply and OK. You can see it selected. It's going to make one pass on the line. We're going to add ramps, and we're going to actually, for right now, is just take the ramps off. This one, we're going. It's a good idea to get used to with using these. Set it as a ramp, but we're gonna do another profile first, and this one will not be needed on here. So we'll call it what we want. We'll rename it, and this will be raster profile 1 inch spoilboard pass 2. I'll show you why that pass 2 is important in a minute. Tell it to calculate, and there's our tool path. And you can see which direction it's going to start in the lower left corner and go back and forth till it finishes at the top left corner. So real quick, we're going to run back over and set it on 2D view, run back on the other side, and we're going to create a rectangle around this whole outside of our spoilboard at the extents. So we're going to set lower left corner 0, 0. We're going to make sure this is set to square. We don't want any rounded corners. And then we're going to set the width at 32.125 and the height at 32.125. Hit create. And this created a file. Let's go back to toolpath side. We'll turn off that. And you can see that vector. And we hit node, and you can see it made a vector that starts in the lower left corner and goes up and around and back. So with that selected, we're going to hit profile again. We're going to leave the same parameters. They hold the same parameters between cuts, so it holds the same tool. We're going to start at 0, cut depth 0.02 using a white side 1 inch bit. On the line, add ramps. 3 inches is a good ramp on this, and then we're going to call it profile 1 inch spoilboard square pass 1. And now to move these, to change the order, I'm going to click on the bottom one and just move it up, and that way we have both of our files. You can see both of them here. You can see them laid out here on the 2D view. Now that is all we have to do is keep this pretty simple and go and run this file. So to finish creating it, I'll have both of them selected. I can real quick hit the time clock on here and hit toolpath summary. It says it'll take about 20 minutes to run. Realistically, since this is a lot of straight lines, it doesn't take that long. It takes about 1.4 at that. So at 13 minutes, that's probably a little bit closer, maybe just a hair longer. Hit close. We'll hit save toolpaths. Make sure you say output all visible toolpaths to one file. We use the same tool the number of the tool is number 1 for 1-inch spoilboard file. We select Onefinity and save toolpath. Now I can call this 1-inch white side spoilboard file for Onefinity. And then this is for video. Now I've got my file saved. I can come up here and save my file, save as, and I'm going to name it the same thing with for video. Now I'm going to show you something else. Since you won't run this file real often, but you'll want to keep it and run it. And once you've got the G-code file made, just rerun it occasionally when you want to clean up your board. When it starts getting roughed up, go up there, home it, set 0 to all. Then you will go and flip your probe upside down on the spoilboard and 0 the Z with your spoilboard bit in it on top of that probe upside down. When you're finished, put your probe up, pull the magnet, hit play, start your router, and let it run. You want to make sure and let this run until it's touched all the spoilboard. If it runs once and hasn't touched it, then we're going to 0 on the spoilboard again and hit play a second time. We're going to keep doing that as many times as it takes, and it'll take off 20 thousandths of an inch every pass. Now that we've got this saved, let's go to Edit and Notes, and we're going to come up here and put a period on that top line. That tells you to open this automatically when you open the file. And we're going to make some notes and say 0 lower left corner at home XY probe spoilboard Now you've got some notes in here. You can tell yourself per pass with 1 inch white side bit, set surfacing bit. Now I've got some notes and I've got this saved, so when I close it, we'll tell it yes, save it. I will come up here and tell it to open this back up. It comes open and you see, notice notes are the first thing that pop up, so I have some information. It tells me that I have notes in there. Tell it okay, I'm ready to go. Sometimes I just need to open that to see the file and to make sense of what I'm doing.
In order to surface your spoilboard, we need to create a toolpath. I use Carveco Maker for all of my design and toolpath creations. So we'll do that here. We'll open up a new model and we're going to make the width 33 inches and the height 33 inches as well. You might ask, why do we do 33 by 33 when the actual carving area of the Onefinity is 32 1/8 by 32 1/8? If we were to look at the actual bit itself, it's a 1 inch diameter bit. So from the center line, you have a 1/2 inch radius on either side to give you your 1 inch diameter. So the maximum size that the center line of the router and the shaft of the bit needs to travel is going to be 32 inches by 32 inches, which is inside of the cutting area of the Onefinity. And that's why we're doing 33 by 33, in case our spoilboard is just a tad wider or longer than 32 by 32. Okay, the other thing I like to do is to, when doing the spoilboard, is to put my origin point or datum point in the center. So we'll hit OK. All right, so there we are. We then come in and create a square from one corner to the other, and that's 33 by 33, and you can verify the dimension here under the size. We'll go ahead and create that. Now that the rectangle, or square rather, is created, we'll come in and we'll create the toolpath. So we're going to do an area clearance, and what I do here is the start depth is 0. The finish depth, I'm going to do 1/64 of an inch, which is 0.015. And we're going to go ahead and select the surfacing 1-inch surfacing bit, which is right there, and we'll select that. Once you've selected that, it gives you some of the parameters, cutting parameters of that bit, and the feed rate is showing as 80 and the plunge rate is 30. A lot of the software programs are very conservative on their feed rate and plunge rate. Because we're only taking a 1/64 of an inch off the spoil board, we can certainly increase that speed, and I'm going to move this from 80 to 130 on the feed and from 30 to 50 on the plunge. The other thing I'm going to do is look at the offset strategy for clearance. What that will do is it will start in the center and start working its way out in a square pattern all the way till it hits the edge to clear that. And then the last thing we do is set up our material to 3/4 of an inch thick. And we'll hit OK. So we can give the toolpath a name, or you could just leave it blank and hit calculate, and it will populate a name for you called Area Clear. So as you can see, because of this strategy, what it does is it starts in the center and it works its way out. And so you have concentric squares going all the way from the center to the outboard edges. And I like using this strategy because, as you can see here, you have horizontal lines on the front and the back, and then you have vertical lines on the left and the right. If you run the strategy and you run your hand over the spoil board after you've surfaced it, and you could feel ridges where your nails catch on it, looking at these lines and the ridges that are in your spoil board will dictate which direction you have to tilt your router head to get a smoother, flatter surface. So that's why I like using this strategy. 9 out of 10 times, there's very little tramming that needs to be done. So now that we've got this calculated, we can go ahead and save the file, and we'll save it under surfacing 1-inch diameter bit. We'll hit save. We'll go ahead and copy that to a USB thumb drive, and we'll take it out to the shop and start surfacing the board. Okay, one of the first things that we do after we've turned our machine on is home the machine. So let's go ahead and do that. So what I like to do is to take a reading to find out the height in about 4 or 5 different locations, and I'll use the probe to do that. Be careful, some surfacing bits won't probe real well, and you'll start driving that into your probe. So always check the continuity first. Okay, so as I look at this, it's showing our absolute as minus 0.4344, 4.344 inch. So I'm going to mark that down front. Left is 4.344 inch. And now I'm going to move to 3 or 4 more locations on the table, and we'll try doing that again. Okay, so we'll probe back here. Okay, we'll hit probe Z. Okay, so over here we've got 4.327. And we're going to probe here for Z. Okay, so here we've got a right right rear, and this one has minus 4.361. So far that's the lowest spot on the table. Okay, we'll take a reading here, and we'll probe Z again. Okay, this one is 4, here's the front right, and it's minus 4.368. 4.368. All right, so the front right is going to be the lowest point. So what we'll do is we'll set 0 there. The reason being is if you take it at a high point and you're only taking off a 64th, it's not going to get down to that low point. And so consequently, you're going to have to take multiple passes at it. So we'll set it at the lowest point. Now that we have the Z0 set, we need to set the X and the Y. The Onefinity cutting area is 32.126 inches by 32.126 inches. And as you recall, we set our origin point for the surfacing file to be in the center. So we need to zero our X and our Y to 16.063 inches for X and 16.063 inches for Y. Now you could do it with your joypad. And as you watch the screen, you can see how close you're getting to it, and then you have to jog a little bit to find that 16.063. And it's very fussy to hit it right. So I like to use the MDI command. And so basically, let's return this home. Okay, so in the MDI command, you would select the MDI tab, and you have two different commands. You've got the G00 command, which will move at the rapids rate, and the G01, which would move at the feed rate. So if you did G01, X 16.063, Y 16.063, it would move over there, but it would move over at a probably slower rate because the feed rate is not as fast as the rapids rate. So I like to use the G00 command with the X 16.063 and the Y 16.063. So I'll do that right now. I'll just enter G00 X 16.063 and Y 16.063. And then I'll hit the play button, and you'll see the machine move. And it goes right into the middle of the cutting area. At 16.063 times 2 would give you 32.126. So that's why we do it that way. And it's always going to be smack in the middle of your board, middle of your cutting area. In this particular case, because we're using the 1-inch surfacing bit, we know that it can technically cut up to 33 inches following a 32-inch path. the surfacing is completed, I can run my hand over the spoil board and I don't feel any ridges whatsoever. I previously trimmed my machine and so I knew it was going to be good. So that's how I do my spoil board surfacing. And I know a lot of folks, I've seen posts out there about cutting into my wasteboard. I don't want to do that. I usually put something else under it. That's what it's for. It's a spoil board, so that you don't mess up your tabletop or cut into your tracks or inserts. So don't be afraid to know that, because these are easily replaced. Mine are 6-inch wide slats, and so I've got a sheet of MDF that I've cut to the 32 3/4, and then I just put them through the table saw at 6 inches, and I've got probably 8 or 9 of them ready to go if I need to. I pre-drill the holes to mount it to the table so that they're in the same spot all the time. And if you don't want to cut into your spoil board, always caliper your material, and when you're designing, make sure that you put an accurate thickness on there, and you'll have less chance of cutting into your spoil board. Don't do what I did. I had some 7/8 material cherry, and that's what my design was in. And then I decided that it wasn't quite flat enough, so I ran it with a surfacing bit and got it down to about 3/4 of an inch. But I neglected to go back into my design and change that to a 3/4 inch thickness. So I put a nice little 1/8 inch carve into my spoil board. No big deal. That's what it's there for. If you don't want to cut into your spoil board and you don't have a set of calipers to caliper your material, you can always do your profile cuts, anything that's going to go through the material, and set it from the spoil board, not from the top of your top of your model. So that's just another little tip that will help preserve the spoil board a little bit longer. Anyway, that's pretty much it as far as the way I do my spoil board. I use Carveco Maker to design, and I know where the exact center of the cutting area is, and as long as the center line of the bit doesn't exceed that 32 1/8 or 32.126 dimension, it's not going to give you the error messages. You might get an error message when you do your probe Z. If you do, you might need to bring your bit down just a little bit so that it will touch the surface. You probably also noticed that when we started cutting, there were certain spots that looked to be more than a 1/64 of an inch. Remember, we took the lowest dimension here in the front right corner, and when this was almost completely cut, I could barely see what material was left, and it was probably less than a 1/64 of an inch before it made its final pass and cleared the whole tabletop. So anyway, that's it. Hope this helped you guys. You guys have a great day. Thanks.